Okay, this is lesson 1.6, and in lesson 1.6 we're going to begin looking at transformations. You did some transformations in grade 10 when you looked at quadratics. Graphing the parabola, you would shift it left and right, up and down, according to where the vertex was, the h and the k. Moving any other function is pretty much the same strategy. You're shifting points left, right, up, or down. You can also stretch and compress and reflect, and we'll go into those in later lessons, but this lesson is just about shifting left, right, up, and down. So first, let's consider the transform function. Instead of y equals f of x, which would just be a parent function, f of x, this function has two different transformations. X subtract d, so something's happening inside the function to the x's, and plus c outside the function, so adding to the f of x, so adding to the y's, which is going to change the y's. So d is acting directly on x, and c is acting on f of x. F of x, as we recall, is just y, so the c's impact y, and the d's impact x. F of x could represent any of the parent functions, linear, quadratic, square root, reciprocal, absolute value, and c and z both result in translations, which is like a slide, a left, right, up, down shift. And the way it works is whatever d is, adds to x. If d is a negative number, well then obviously it's subtracting, but adding a negative is the same as subtracting, so it's subtracting. And negative would be going in the left direction because you'd be going left on the number line, subtracting is to the left. Adding to the right and acting on the y's, you have up and down shifts. So if c is a positive value, we're going up, and if c is a negative value, we're going down. This chart should summarize the shifts. C acts exactly the way it looks like in the equation. If c is greater than 0, the translation is up, however many units c is. If it's negative, it's down, however many units c is. Horizontal is the one that's a little tricky. Since the transformed function x minus d, the appearance of what d is actually the opposite because of that negative sign. If d was a positive number, the bracket would say x minus the positive number. And if d is a positive number, the shift is to the right. But in the equation, it would look negative. So we have to be very careful with our d. And we'll look at that in more detail. So let's give these slides and translations a shot. First thing we're going to do is, well, I've drawn a figure here on the graph. It's a triangle. I just connected 3 points just so you can see what the translation actually looks like. And moving a whole figure is easier than just looking at shifting points. But here we go. Let's start with our first translation. All we're going to do is we're going to take these points and we're going to shift them upward. So A is just going to be a shift upward, and to do A, I'm just going to, I'll do it in black pen, but then I'm going to highlight it yellow. So yellow is going to be our upwards one. So basically I'm just taking all these points and I'm going 1 unit up. So that would put this point here, that would bring this point up to the y-axis, x-axis, sorry, and it would bring this point up another point. And if we connect them, we end up with this graph. And if I highlight, try not to smudge, there's our shifted graph for A. The x's didn't change. It didn't go left, right. It only went up. Let's try B. B, I'm just going to shift 4 units to the left. I'll do B in pink. And we're going to take our original, and we're just going to shift each point 4 units to the left. So here's my 0, 0. I'm going to bring this point all the way to the left to -4. This point that started at 1 for x, I'm going to bring all the way to the left 4 units, which would take me to -3. And this point that started at 3 on the x scale, I'm going to bring 4 units to the left, which would take me all the way to -1. And if I connect my dots, I've got the same triangle. Notice the shape isn't changing, just the position on the graph. And when you're doing translations, the shape does not change. Its appearance on the graph could sometimes change. Like if you're shifting a parabola up and down, it might look skinnier or wider. It's just because more of the parabola is actually on the paper. The actual graph hasn't changed in shape. Last one, I don't know how to highlight with a pencil. I'm just going to do C with a pencil here. 2 shifts at once. 2 units right, 3 units down. And I'm going to go from the original again. I'm going to do 1 point at a time, and I'm going to go right, then down. So we get first point 0, 0. 2 units to the right would take me 1, 2. 3 units down would be 1, 2. Sorry, count that again. 1, 2, 3. Top point, 2 units right. 1, 2. 3 units down. Takes me all the way down to, hey, a shared point. And our last point, 2 units right. 1, 2. 3 units down. 1, 2, 3. And if I connect the dots, again, same shape, different position. So what's happening here? Let's write our general rule. I kind of already showed you the general rule at the top, but here's what's happening. Basically, whatever we're doing left and right is acting on the x scale. The one where we shifted it to the right, or sorry, to the left 4, we just took our x of 0 and we moved it 4 to the left to -4. So basically we took our x and we subtracted 4. So our d is acting on x. So what we're going to do is we're going to add whatever d is to x. And that looks like this, x plus d. And we're going to add whatever c is to y, because the shift up down affects the y scale. And this is the beginning of something that we're going to come to learn as mapping notation. It's how you can take an original point and change it using any of the transformations. And now we've done 2, d and c. Okay, the instructions for question 3 actually ended up on the bottom of this page. Sketch the transformed function using the parent function, the square root of x, the positive square root. And that's the one I'm going to get you to try. So I've graphed it here. And to do the transformations, what I would recommend is taking a couple key points off of this curve and using them to translate. So there's some nice ones that follow nice on the grid line. So 0, 0 is a good one. 1, 1 is a good one. 4, 2 is a good one. And if 9 was on the scale, 9, 3 would be another good one. It's not. So I would just use these 3 points to do the transformation. So if you want to try A, B, and C on your own, that'd be excellent. You can pause the video now and try it and then check the answers, or you can do it at the end of the lesson. Done the same way as the one we just did together. All right. So back to our parent functions. Here's the 5 parent functions we graphed. Let's show what the equation would look like if we had a D and a C and both. If we had a D on the y equals x equation, basically it would look like this. You would have a x minus d. So in the equation it would say like x minus 2, and that would tell us that d is 2. If there was a c, it's hard to tell, but we would just have c added to x as well, which looks kind of similar to this one, and it's hard to tell which one's which. And the reason why, because for the linear, it actually doesn't matter. Shifting up would be the same as shifting, up would be the same as shifting right. Is that right? Up, right. Yeah. No, that's wrong. Up would be the same as shifting left. And if we shifted 2 units left, it would be the same as shifting up, because the equations would end up the same. If you want to show both, really, it just looks like this. Dx on x in a bracket plus c on the outside, but that bracket is actually unnecessary, so d and c can have a counteracting effect. If you took a graph and you shifted it 2 to the right and then up 2, you'd end up in the exact same position because the equation would end up the exact same. And that might be a little complicated to understand. But if you play around with transformations of a line, you kind of see what I'm talking about. Where it's a little bit more clear is for the other parent functions. If you have a D, a shift left right, or horizontal translation on the quadratic, the parabola, it would look like x minus d in brackets. just like h and k when we were doing quadratics last year. If you had a vertical shift, well, that acts on the entire function, and the entire function is x squared. So if you're adding to x squared, it would be outside the squared. Notice, the horizontal shift acts directly on x inside the function. The function is the squared. Squared is the function. D, inside the function. Vertical acts on the function, outside the squared, plus c. If you have both together, it would look like this. X minus d, d acting on x directly inside the function, inside squared, c acting on the whole function outside. I'll do one more and then I'll get you to try the last two on your own. D acting directly on x inside the function. The function is the square root, so the equation would look like this. Square root of x minus d acting on the function on x inside the function square root. C, square root of x, acting on the whole function outside the function. Square root of x outside plus c. Both together, square root of x minus d plus c on the outside. All right. I'm going to show you a couple concrete examples so you get to see exactly what I'm talking about below. But you can try these two. Show me where the d and c would be. Remember, d acts on the function, so it acts directly on x. So wherever x is, put the d there. Put minus d there, inside the function. Wherever c goes, outside the function. So whatever the parent function is, outside. So if it's the fraction, outside the fraction. If it's the absolute value, outside the absolute value. That's where c goes. To really hammer this idea home, here are some specific translations. I'm going to put them exactly where they should go. Okay? Translated 1.5 units to the right. That's d. D is 1.5. Now we're going to the right. Right is positive. So d is 1.5. C units down. Units up or down is c. Since we're going down, it's negative. So c is negative 2.5. So here we go. Here's what the function would look like with these two transformations. F of x equals the square root of x. D, the shift left right, acts directly on x inside the function. On x, inside the square root. To the right, it's positive. But in the parent function, we have a minus d. We always subtract d. Subtract 1.5. C acts on the whole function. The whole function is square root, so outside the square root, minus 2.5. Here we go. Let's reconsider what this equation says. X minus d. D is 1.5. A 1.5 for d means a shift to the right, 1.5. Outside the function. Function's here, square root, outside the function. That's where c is. Adding or subtracting outside the function, c. C is negative, so we're going down. How much? 2.5. Down 2.5, right 1.5. Domain and range for the following. What would the domain be? Well, let's think about what this parent function looks like. It's the square root, so I'm going to sketch it here. The parent square root looks like this. And if I shift it to the right 1.5 and down 2.5, to the right, down, this is just a sketch, it would look like this. Down 2.5, right 1.5. So that means it would start at 1.5 and it would go up on the x scale. So the domain, since it's a curve, x belongs to real, such that we're starting at 1.5 and we're getting bigger. X greater than or equal to 1.5. It goes on forever, so it keeps going. Starts at 1.5. It's a solid circle, a dot. It starts there, so it includes equal to as well. So x belongs to real, x greater than or equal to 1.5. Range. Y's. Y's belong to real as well. Where do the y's start? Well, the y's start at negative 2.5. And we're not going down from negative 2.5, we're going up. So we're greater than negative 2.5. It starts there, closed circle, equal to. There's our domain and range. you can try B. That's it for lesson 1.6. Be sure to try the examples that I haven't done and check your answers on the course website. Thanks for watching, and I'll see you next time.